Hello everyone, welcome back to logicbinder. In today's video, we shall discuss about the construction of a DFA which accepts the strings of even and odd combinations of A's and B's. First example is construction of a DFA which accepts the strings of even A's and even B's. Let L of M is the language. The sample strings we have taken as ABAB, AABB, BAAB, so on. The minimal automata is from the initial state we need to process even number of A's and even number of B's. So here in the minimal automata we are processing from the initial state Q0 odd A, odd B, even A, even B. So we can make this initial state as a final state. Thus here we have processed the even number of A's and even number of B's. This is the minimal automata. The sample string is AB, AB, which contains even number of A's and even number of B's. Based upon this, in the next step we have to construct the DFA. In the above minimal automata, we have already processed Q0 on A, Q1 on B, Q2 on A, Q3 on B. So this is making a even number of A's and B's with final state as Q0. For this minimal automata, now here we are giving the remaining input transition for each state. So Q0 on A is already completed. Remaining is Q0 on B. So Q0 on B is connected to the Q3 state. Similarly, Q1 on B already we have given in the last step. Remaining is Q1 on A. Q1 on A is connected to Q0. And Q2 on A is already processed. Remaining is Q2 on B. We are connecting to Q1. Similarly, Q3 on B is already completed. Remaining is Q3 on A. We are connecting it to Q2. So that in this automata, we observe that even number of A's and even number of B's are processed through the initial state Q0 and the final state Q0. Observe the sample strings here. We have considered the sample string as AABB. Here Q0 on reading A is moving to Q1. Q1 on reading A is moving again to Q0. Q0 on reading B is moving to Q3. Q3 on reading B is moving to Q0, which is the final state. If any string is passed through the final state, we can say it is a valid string which is belonging to the language L of M. Next string is BAAB. In this string, the initial state Q0 is reading the first input as B. Q0 on B is moving to Q3. From Q3, next input is A. It is moving to Q2. Q2 on reading A is moving to Q3. Q3 on B is again moving to Q0, which is a final state. Thus, the string BAAB is also valid. One more example is construction of a DFA which accepts the strings of even A's and odd B's. Let L of M is a language. The sample strings we have taken as ABA, AAB, BAA, BBA, so on. In all these strings we are having even number of A's and odd number of B's. Construct the minimal automata. In the minimal automata, we have to process odd A, odd B, then even A. Upon completion of processing even A, we make this state as a final state. So, from the initial state Q0, process odd A to Q1. From Q1, process odd B to Q2. Process even A. Second A is nothing but even A. Process even A to the state Q3. So Q3 will become a final state here. Similarly, process even B, but this is a non-final state. So upon reading the even number of A's, the corresponding state will become a final state here. Here in the minimal automata, we process a basic string as A, B, A, which contains even number of A's and odd number of B's. Then after, based upon this, we have to construct the DFA. Based on the minimal automata, upon giving a remaining transition for each state, we get the complete DFA. Q0 on A is already processed. Remaining is Q0 on B. Connected to Q3. And Q1 on B is already processed. Remaining is Q1 on A. Connected to Q0. Similarly, Q2 on A is already processed. Remaining is Q2 on B. Connected to Q1. And Q3 on B is already done. Remaining is Q3 on A connected to Q2. If you observe here the states will have the same input transition for each combination. Either it is even A's, odd B's or odd A's, even B's. But the thing is that The states are getting changed for a final state. In the earlier problem, Q0 is becoming final because in that combination we have processed even A's and even B's. Odd A, odd B, even A, even B. So making Q0 as a final for even number of A's and even number of B's. But here in this problem we have to process even number of A's and odd number of B's. So odd A, odd B, even A is processed. Q3 will become final state here. So upon changing the final state, whether it is Q0, Q1, Q2, Q3, we get multiple combinations. Now consider the sample strings which are processed through this DFA of even A's and odd B's. A, B is a sample string. From the initial state Q0, A is reaching Q1, Q1 on A is reaching Q0, and Q0 on B is reaching Q3, which is the final. So AAB is accepted by the DFA. And the next input string is BA, BBA. Q0 upon reading B is reaching Q3. Q3 upon reading A is reaching Q2. Q2 upon reading B is reaching Q1. Q1 upon reading B is reaching Q2. Q2 on A is reaching a final state which is Q3. Thus, these two strings are accepted by the DFA of even number of A's and odd number of B's, which are valid. Next combination is DFA accepting the set of strings of odd number of A's and even number of B's. Let L of M is a language accepting odd A's and even B's. The sample strings are A, B, 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 A, B, A, B, B, A, so on. Here in all the strings we are having odd number of A's and even number of B's. The minimal automata should process odd A's and even B's. Here Q0 on odd A is processed to Q1. Q1 on odd B is processed to Q2. Q2 on even A is processed to Q3. Q3 on even B is processed to Q0. Since here Q0 upon reading A, which is odd A, is processed to Q1, we are making Q1 as a final state. For even number of B's, even 0 number of B's is considered as a even number. So here in this combination, Q0 upon reading odd A to the Q1 state, we make this Q1 state as a final state. Upon giving a remaining input transition on each state, we observe the complete DFA. Considering the minimal automata, we have Q0 on A to Q1 which is already processed. Remaining input on Q0 is B. So Q0 on B is connected to Q3. And Q1 on B is already connected to Q2. Remaining input is A. So Q1 on A is connected to Q0. Similarly, Q3 on B is already connected to Q0. Remaining is A. Q3 on A is connected to Q2. Here, if we observe, the DFA is processing odd number of A's and even number of B's through the final state which is Q1. Observe the sample strings. The strings we have taken as ABB and BAB. For this string ABB, Q0 upon reading A is moving to Q1. Q1 on reading B is moving to Q2. Q2 on reading B is moving to Q1 which is a final state. Since the string ABB is accepted through the final state, we can say the string is valid. Next is BAB. Q0 on B is moving to Q3. Q3 on reading A is moving to Q2. Q2 upon reading B is reaching a state Q1 which is a final state. Thus the string BAB is also valid string. Now the last combination is the construction of a DFA which accepts odd number of A's and odd number of B's. Let L of M is a language. The sample strings we have taken are BAA, BAB, AB, BBAB. Here the minimal automata will be processing the basic string. The basic string we have seen is AB here. In all the combinations Q0, Q1, Q2, Q3 will have the same transitions here, but the final state will change depending upon the combination of a language. Here Q0 will process odd A to Q1, Q1 will process odd B to Q2. Odd A, odd B is already processed, so we can make Q2 as a final state, then even A, even B, which are non-final states here. So upon given remaining input transitions, we make it as a complete DFA. Based upon the minimal automata, we have to give the remaining input transition for each state. In the minimal automata, Q0 on A is already done. Remaining input is B. So Q0 on B is connected to Q3. Q1 on B is already completed. Remaining is Q1 on A. So Q1 on A is connected to Q0. And Q2 on A is already completed. Remaining input transition is Q2 on B. It is connected to Q1. Similarly, Q3 on B is already completed. Remaining is Q3 on A. Q3 on A is given to Q2. Based upon this DFA, which is having complete set of transitions of odd number of A's and odd number of B's, we observe whether these strings are processed through the final state or not. String AB, Q0 on A is moving to Q1, Q1 on B is moving to Q2, which is the final state. This is valid. String BA, Q0 on B is moving to Q3, Q3 on A is moving to Q2, which is also valid. And the string ABBB, here Q0 on A is moving to Q1, Q1 on B is moving to Q2, Q2 on B is moving to Q1, again Q1 on B is moving to Q2, which is a final state. Since all these strings are accepted through the final state, these are valid. Thus the DFA which we have plotted here is a valid DFA.